Hi everyone. This is the script for the 6th week. We are gonna do some exercise on the things you have learned this week. So we're going to talk about null values. We will see how to create aggregations, group bys, and nested queries. As usual, I have a script that I'm going to follow, and I will upload the script to Moodle together with this video clip. So let's start from the beaver. You can see it here. And as always, you have your databases here. In this case, I have a database without tables. You can see that it's empty. And the very first things we're going to do, of course, we're going to start a SQL editor. And we're just going to create some tables. So the first parts, I'm just going to copy paste as they are. It's absolutely nothing new. So we have the dropping of some tables if they already exist. And then we create the reader, the genre, and the book. So let me just run the whole script, refresh this, and see that the tables are there. Okay, next thing, we're going to insert some data. So let me copy this. This is also nothing new for you. So we are inserting a couple of readers, a few genres, and some books. We do it one at a time. Actually, we can run the whole script again. It's easier. Okay. Let's just make sure that things were inserted. Select star from LTS reader. There are the readers. Select star from LTS genre. We have the genres, and select star from LTS books. And we have the books as well. So far so good, nothing new. Now for this specific exercise, I want to create another table as well. So let's have a look at this new table. It's the rating table, and it includes two foreign keys, one to the book and one to the reader. And then it includes the rating that the reader gave to that book. So let me create the table, refresh to make sure it exists, and let's see which kind of values we can put in this table. So you see here, I'm inserting 1, 2, 3, 4, 5 ratings with values 3, 1, 5, 5, 1 from different users, different readers to different books. Let's do that. And let's make sure one more time that everything is where it needs to be. Sorry. Yes. Rates. Okay, we have all our rates. So now we can start looking into the new things you learned this week. The first one is how to handle null values. For doing that, we can start actually from the book table. So sorry, from the reader table. If we look at this one, you see you have two readers with middle name set to null. So let's see what happens if I do something like this. If I'm asking the system to retrieve all the readers with middle name null. Well, if I run this, maybe you are expecting to find two records, but the reality is that you get nothing. And you have already seen this, the reason in the slides. The reason is that this is not the correct way to compare an attribute to null. Null means I don't know the value, so the equal doesn't really perform well for us. Instead, we need to use an operator. So if we run something like this will actually work properly and give me the two rows with a null middle name. You also have a not null operator, which of course in this case doesn't return anything because we don't have any record with middle name not null, but this is also working properly. So null values also have a specific way to be treated by aggregation function. So let's start looking into aggregation functions. And let's start with something simple. Suppose we want to count how many rates we have in our table. We do something like this. We've got 5 of them. This is okay, because if you look at the table here, indeed you have 5 rows, 1, 2, 3, 4, 5. However, we know we have 2 readers, remember from here, we have 2 readers. But if I try to count now the readers in this way, then everything is good because I'm counting the number of rows, so I'm getting 2 rows. Okay, so this is fine. But if instead I'm trying to count the number of middle names, in this case I'm going to get a 0 because the null values are always disregarded with aggregation functions. So they don't appear in counting, they are not considered when you do a sum, an average, a mean, or a max. So keep it in mind, null values are not considered by aggregation function. You have also learned that there are several aggregation functions. So for example, we can calculate the number of rates we have, the sum of them, the average, the mean, and the max. When you go to the script that I'm uploading on Moodle, pay some attention to the comments that I have. Here, for example, in the script, there are some comments on how the average is calculated. So if you look at this, in a DBMS as SQLite or MariaDB, the average rate is automatically converted to a double or a float number. So it will actually give you 3 point something if it's needed. But in other DBMS, like Microsoft SQL Server, the result of any aggregation function is always of the same type as the attribute. So if this attribute is an integer, like we defined it here, then the results of a sum, aggregation, or even an average will always be casted into an integer number. And there are tricks, workarounds on how to get them to be a double, but this is something we're not going to cover now in this course. So keep it in mind, for SQLite and for MariaDB, you actually get float numbers here. In other DBMS, you will need to do some tricks to get the correct values out. Okay, the next thing I want to discuss with you is this. So what happens if I do something like this? If I ask to go through this table, remember we can think of a table as a bucket which contains different rows, right? And I'm asking to provide me the counting of those rows. So in this case, number 4, for example, if this was the case. And I'm also asking to provide the rate. Now, this kind of instruction doesn't really make sense because I'm asking for two values which have different granularity with respect to this table. This counting has granularity of one value per table. Over this table, I want to calculate one value only. However, this one has different values for each row. So a statement like this is very confusing and you should just not write it at all. Again, some DBMS like SQLite will actually allow you to run it and it will just give you a random value here. We'll pick up one random value between the rates. Other DBMS like Microsoft SQL Server will give you an error if you try to run something like this. So be aware that you need to return values at the same granularity, otherwise it just doesn't make sense. So if I want to do something which is actually more meaningful, I can do something like this. I can use the group by. So now I'm saying that if I have different rows, I want to group them by rate. Suppose that these two have rate 1, both of them. So this one has a rate of 1, this one has a rate of 1, this one has a rate of 2, and this one has a rate of 2. So I want to group these two together and these two together. And then for each group, I want to evaluate the rate and the counting. Now these have the same granularity because if you build a group here, there is one value for the counting of the row, 2 rows, and there is one value for the rate because it's the same rate value across the entire group. So now this makes sense. I can run it and it tells me that for the rate value 1, I have 2 ratings. For the rate value 3, I have 1 rate. And for the rate value of 5, I have 2 rates. You can check this by selecting over the rate table again. Okay, so if I group by, I can put in the select the elements of the group bys or any other aggregation functions. Anything else will just not be meaningful. So if you are grouping by, remember in the select statement, you can only have the elements of the group by or the aggregation functions. Let's look at a different example here. Suppose we do something like this. We are again in the rates. We are grouping by rate, but this time we are asking, again, the rate, the counting, but the email address as well. And again, this doesn't make sense because if you think of grouping 2 rows because they have the same rate value, it means that the rate value is 1 only, so I can ask for it. The counting is 1 value only, and I can ask for it. But the email address doesn't make sense because these two may potentially be 2 different readers. Again, SQLite will allow this, but give you a random value here. Microsoft SQL Server will not allow you to put in the select an element which is not present in the group by. So careful, depending on the DBMS that you're using, You may get some help from the DBMS, or you may not. In this case, it doesn't really help you, just does whatever you're asking, but then you need to give the correct interpretation to that. Of course, remember, we can filter groups. So suppose that I am not interested in the group with only one rate. I can say group by rate, but report only those which have at least 2 ratings. So if I run this, I will only see the rate value 1 and 5 because both of them have 2 rates, while the one with number, let me just run it without the heading, number 3 only has 1 rating, so it doesn't come out when I filter for that. Okay, so we have covered the null values, we have covered the aggregations, and we have covered the group bys. Now let's have a look at the nested select. So suppose we want to, let me just copy the text as well. Suppose we want to do something like this. We want to retrieve all the highest rates. So let's have a look at them again. If you think of what we have in the table, we have the highest rate is 5, and we have 2 of them. So suppose we want to retrieve these 2 rates here. Now, in your lessons, in the PowerPoint, you have seen that you can use any and all as clauses in your select statements. However, SQLite doesn't really support them. So in this exercise, I will show you how you would do it by using those clauses. So for example, you may do something like this. Select everything from the rates for as long as it's true that the rate value is larger than all the rate values in that table. So this means first get all the rates from that table, and then take one rate out only if it's larger or equal than all these rates. So what does it mean? If we start from, let me see, where is the select that I want now? Otherwise, we just write it again. Let me just write it one more time here. Select start from LTS rates. So when you have this kind of statement here, it's like a double loop, right? So we are looping on the outer select. So we are now focusing on the first row, and we are asking ourselves, do we want this row out in the result set? Well, we need to check if the where condition is satisfied. So is it true that this rate 3 is larger or equal than all the rates that I have in this table? The answer is no, because 3 is not larger than 5. So 3 is not satisfied this condition, so it doesn't come out in the output. Then we go to the second line. Number 1, again, it doesn't come out because it's not larger than 5. The only 2 that come out are these 2. So if I could run this select here, I would actually get these 2 lines. However, if you try with SQLite, you will get an error because it doesn't recognize this operator. So how can you do it in SQLite? You can use different operators, something like this. Take everything from rates and select one row only if the rate is equal to the maximum of all the rates. Because the maximum of all the rates is number 5. So again, I go line by line and I take a line out only if the rate is equal to 5. So if I run this, I only get these 2, just as we wanted. Similarly, you cannot use any. So suppose that now we want to address this question. Find all the rates except for the lowest ones. So I want to exclude, in this case, let's see again, select start from LTS rates. So we want to see everything except the ones, okay, which are the lowest. If we could use any, we would write something like this. Get all the lines which satisfy this condition. The rate of that line is larger than at least one of the rates. This is what this means, right? It needs to be larger of at least one of all the rates which are inside. So the only ones which do not satisfy these conditions are this one and this one. So they would actually not be reported in the output. But again, this is not going to work because any is not recognized. We can use exist to do something similar, to actually something that is the same. So take anything from rates, But for each line, you decide whether or not to take it based on this condition. And here, careful, because this is a bit more complicated. I'm giving an alias R1 to this table, and then inside, I have again the same table with R2. So when I'm analyzing one of these, so I'm going again one by one. Suppose now I'm focusing on this line, and I need to understand whether I want to see it in the output or not. So the condition is, I see this in the output if this condition is satisfied. What is the condition? I'm selecting all the rates. Actually, I could even put, I select everything from this rate table, which I'm now calling R2, but I'm only taking those rows which are smaller than the one I'm considering now. So now I'm considering rate 3. This one takes all the lines from here which are smaller than 3. And because I find this one and this one, the exist condition is satisfied. So line 3 is pushed forward into the output. When I go to line 2 and I do the same exercise, now I'm focusing on line 2, which has a rate of 1. So I'm trying to look if I have anything here which is smaller than 1. And because I don't find anything, this condition is not satisfied, and line 1 is not produced into the output. So if I run this, I get all the rates except for the lowest ones. So I know that this is not easy. Spend some time thinking about it. I will upload the script as well so that you can try it yourself. You can also add some data if you want. And if you still have questions after that, feel free to contact me. We will discuss it together.